So decimal to percentage is easy. Move it over twice. You could have put 350 over 100 if you had wanted to. That's technically what it is. But if you can already see that that's set 3.5, then you can make that 3 1/2 and just change it into an improper fraction. Either way, you should get 7/2 there. The next one is find 50% of 3/4. What does of always mean in these things? Multiplication. So if you did it with a decimal, then you would have said 0.5 times 3/4, which is 0.75. And then if you did it as a fraction, you could have just said 1/2 times 3/4. All right. So if you do it this way, that's where they're going to get the 3/8. If you do it the other way, you're going to get 0.375. So next one. So this one says 175% of 18,900 is what number? So we need to change this to a decimal. How do I do that? You're going to move it over 2 places this way, right? So that's 1.75 of, what does that mean? Multiplication. So multiplication times 18,900 is, what does that mean? Equals, what number would I put there? X. So you really should have just multiplied these two. 1.75 times 18,900. If you did it in ratio form, it would have been 175 over 100. Percentage over 100 equals part. Remember, of is always the whole. So part we don't know over the whole like that. And you would have gotten the same thing. All right. The next one says Lydia got 64 out of 75 questions correct on her history exam. What percent did she earn? That's really just 64 out of 75, right? Equals what out of 100? So you're just going to divide and then multiply by 100. Or if you set it up like an equation, you would say 64 is what percent of 75, right? And again, you would get 64 equals x times 75, and you would get 64 divided by 75, which is 0.85, but in percentage it is 85%. Hopefully you're used to this because this is how I put it on all of your tests and quizzes. I give you a fraction and then I give you a percentage, and all I do really to calculate that is divide. The first thing they say here is just like a scenario. If the price of a product increased or decreased by $10, would that be a significant change? Knowing the amount of the change alone is not sufficient to answer the question. Why? Well, what was the original amount? The first thing they say is an increase of $10 on a $1,000 computer. Well, that would not be that noticeable, right? However, if a notebook increased from $5 to $15, that would be noticeable. Like, let's say you went to Chick-fil-A and their sandwich went from whatever it is, $4 alone, I guess, to $14 for a sandwich. You would notice that $10. But if you went to Best Buy and the computer you wanted went up by $10, that's not a big deal if it was $1,000 or $1,500, right? And so it definitely depends on what the original price was as to whether or not it was a large increase, even though the dollar amount was the same. If they went up $10 on a computer or $10 on a sandwich, the amount they went up was actually exactly the same. But comparatively to what it originally cost is definitely not the same. And so this is where you get the concept of percent change. How much did it change compared to the original amount? And so that's exactly how you find it. You take the amount that it changed and you divide it by the original amount, and that is your percent change. Now, the multiplying by 100 is literally just changing it from decimal to percentage. All right, so you're going to get a decimal when you divide the change by the original, and you need it in percent form. So you always want to change that to percent. So let's look at these examples here. So you're doing the amount that it changed divided always by the original amount. Always by the original amount. So let's look at this. A baker decided to raise the price of a loaf of especially bread from $3 to $4. This price resulted in a large drop in sales. So he reduced the price back to $3. Determine both the percent increase and the percent decrease in the price of bread during these changes. It seems as it would be the same, but it won't. All right. So how many dollars did it change when he went from 3 to 4? That's the change amount. Change amount. And that was $1, right? And we're going to put that over the original cost, the original. How much did it originally cost? It went from $3 to $4. So how much was the original amount? 3. All right. If you divide that out, you get 0.3 repeating, which as a percentage is going to be 33%. So if you divide 1 by 3 and multiply by 100, you get 33%. All right. Well, then he wanted to change it back. So he went from $4 to $3. Is this a 33% drop? All right, so how much was the change amount? From 4 to 3, how much is it? Just 1. What was the original amount? 4. All right, that is going to be 25%. So the original amount matters, all right? He went up 33% because it was $3. But then when we went back down, it was actually only 25% down because it started out at 4. All right, so it is always compared to the original amount. Always compared to where you started from. All right, let's look at example 2. Example 2. Last year, 1,056 people voted in the city election. This year, only 912 voted. Find the percent decrease to the nearest tenth of a percent in votes cast. All right. So the first thing we have to do is we have to find how much it changed. So how do we find how much it changed? What's the change? How do we find that? How much did it change? How would you find that? Yeah, we're just going to subtract. Yeah, so we're going to say 1,056 minus 912. That's how much it changed, right? And then what was the original amount of people who voted? How many people voted originally? Right, the original amount was 1,056, all right? So what is 1056 minus 912? 144, and then we divide that by 1056. So go ahead and do that. 944 divided by 1,056. What do you get? It's a decimal. Three decimal places. Yes, so you get 0.136. Is this in percentage? No. How do I change it to percentage? Move the decimal place over or multiply by 100. So you get 13.6%. I want you to notice how they worded it here, because this is very important. Nearest tenth of a percent. Nearest tenth of a percent. Tenth means 1 decimal place, okay? However, you do not round until you've changed it to percentage. So that's why we want to, if we round here, you round to 3 decimal places before you change it to percentage, okay? So if they say the nearest tenth of a percent, then you need 3 decimal places here. 1, 2, 3. So that when you change it to percentage, you still have 1/10 left, all right? Nearest tenth of a percent means that after it has been changed to percentage, you still have 1 decimal place. Nearest tenth of a percent. I do count off for rounding incorrectly, so this is why I'm explaining it, all right? So in this form right here, you want 3 decimal places before you convert it to percentage, and then you will have nearest tenth of a percent. All right, questions on that? All right, let's go over these. It went from 200 to 100. How much was the change? How much was the change? How much did it change if it went from 200 to 100? It went changed by 100, right? What's the original amount of that? 200. So that was a 50%. Was it an increase or a decrease? That was a decrease, right? If it went from 200 to 100, that was a decrease. All right. For the next one, they told you how much it changed. How much did it change? 40, right? My original amount was 590. You should have gotten that that was a 6.8% decrease. All right. So when you rounded it to your nearest decimal with 3 decimal places, you should have gotten 0.068, which is 6.8%. Yeah, and so they also asked for the new amount, which should have been 550. You literally just had to subtract the 40 if you wanted the new amount. All right. Now we're going to actually look at when they tell you, okay, it changed by this percentage, and it increased or it decreased by this percentage. And so this first one is that it increased by a percentage. If the city of Woodridge is projected to grow by 7% over the next decade and its current population is 35,000, how many people should we plan for at the end of the next 10 years? All right. So a couple things you want to pay attention here. Grow by 7%. Does that indicate this is going to be an increase or a decrease? An increase. All right. So anytime you have an increase and you're trying to find the new amount, you're going to take 1 and you're going to add to it the increase, but the increase in decimal form. And then you're going to take that and you're going to multiply it by your original amount. And that will be your new amount. That's an increase. You take 1 plus your percent in decimal form, and you multiply that by your new. Why do you have to do that? Because if you're trying to find out what the new amount will be, not only do you have to have the increase, which is the 7%, but you also have to have the original amount, which is the 1, all right? So you have all of your original people plus 7% of that original amount. And so you do the 1 plus that, and you multiply by your original, and that will give you your new. So what is 7% in decimal form then? Yeah, it's 0.07. So 1 plus 0.07 is easy, just 1.07. And we are going to multiply that by the original amount. What's the original amount that they had right now in population? 35,000. So when we multiply that, we get 37,450. And that is the expected population. Now, if you get a decimal here, you need to round. I didn't tell you that in the instructions, but why do you think you would assume you would round to a whole number here? So let's look at example 4 here. Through dedicated training, a runner was able to decrease his time in a marathon by 13% to a time of 2 hours and 47 minutes. What was his time previously? So now we are not increasing, we are decreasing. And so for decreasing, you're going to take the 1 and you're going to subtract the decrease, again, in decimal form. And then you are going to multiply that by the original, and that will give you the new. All right? So what was his decrease percentage? Decrease. How much percent did he decrease? 13%. So 1 minus 0.13. What is 1 minus 0.13? All right, so 0.87. What was his original time? His original time. That's actually what we're trying to solve for, isn't it? This is his new time, a new time. He decreased it to a time of 2 hours and 47 minutes. So do we know his original time? No, we don't. So we're going to put what there? X. Now, I will say when they give you hours and minutes, you either need to do it in decimal form or you need to do it in minutes and then convert it back. So I think it's probably going to be easier just to do it in minutes, right? Because we know how to do minutes. 2 hours and 47 minutes is going to be 2 hours of minutes, which is how many minutes? How many minutes in 2 hours? 120 plus your 47. So it's 167 minutes, right? Or if you want to do it as a decimal, it's 47 out of 60. And so then you have to calculate that decimal. So it's usually easier just to do minutes here. So we'll say 167 here for minutes, all right? So then how do I find his original time? What's happening between the 0.87 and the x? Multiplication. So what do I do to solve? Division. What is 167 divided by 0.87? $167 divided by 0.87. It's going to be bigger than 167. 192, I think they round, right? 192, all right? That's in minutes. You think we're going to leave it in minutes? No. How do I figure out how many hours I have here? Yeah, divide by 60. What is that divided by 60? How many times does 60 go into 192? 3 times with the remainder, not a decimal. With the remainder. What is 3 times 60?
180.
180. So we're just going to take 180 and we're going to subtract it from that. So 3 hours. That's how many full he has. What's his remainder in minutes? 12 minutes, right? Does everybody see how we did that? You're going to use remainder form here, not decimal form. If you get a decimal, what can you do with it if you want to find your minutes? Multiply by what? How many minutes are in an hour? 60. So if you got a decimal, so if you got 3 point, whatever, 12 minutes is going to be what, 1/5? So 3.2, I guess, is what you would have gotten there. You could just say 0.2 times 60, right? And you would get 12. All right. So if you use your calculator to do it, you can multiply that piece, the decimal piece of it, by 60, and you will get the minutes amount there. So when it is an increase, 1 plus your decimal times your original is your new. When it's a decrease, it's 1 minus your decimal times your original equals your new. All right, so I want you to try 2 of these. Page 119, 6 and 8. 6 and 8. So percent error is figuring out how far off you are from where you should have been on something. Typically with like experiments, you'll see this type of thing in like a chemistry or a physics. Manufacturing does it as well. They'll have a limitation on how something has to be manufactured, and there'll be allowable percent error where it will still work. And so the percent error is pretty much this numerator. This numerator is your experimental error, how much you were actually off, the amount you were off. And so that is what you actually got when you performed the experiment, subtracting what the known amount was or what you thought you were aiming for. And then you're going to divide that by what you were actually wanting to get. Multiply that by 100 and you will get your percent error. So this numerator is actually called your experimental error. So your experimental error is just what you got subtracting what you think you should have gotten. And so that this part can be positive or negative because you could be higher or lower than what you thought. When you calculate the percentage, though, you'll notice these little marks on either side of it. What do those marks represent? Absolute value, which means you're going to change that to positive when you calculate the percent error, okay? So let's look at the word problem here. In chemistry class, Jonah determines the density of copper to be 8.83 grams per cubic centimeters, while the accepted value for copper's density is 8.96. Determine his experimental error and his percent error. So if we want his experimental error, we're going to get what he actually got, 8.83, and we're going to subtract what it is the known value, 8.96. So when we do that, we should get negative 0.13 grams per cubic centimeters, okay? So you're just subtracting. Experimental error is literally just subtracting what you got when you performed the experiment or whatever you were doing, subtracting what you expected, all right? What you expected. That's experimental error. And then they want his percent error. So we're going to take this guy, absolute value of negative 0.13, and we're going to divide it by this known amount, the 8.96. And we do want that in percentage, so we're going to multiply that guy by 100 or move the decimal place. All right. And you should get 1.5%. They want 1 decimal place. So that means he was 1.5% off of where he thought he would be. They're not asking whether he was higher or lower. We know he was lower. How do we know he was lower? Because this guy was negative. All right? He was lower than what he thought. They just want the percent he was off, 1.5%. That is percent error. You just subtract what you got from what you thought you were going to get and divide it by what you thought you were going to get. All right, let's look at percent difference. Percent difference. This is similar, but we're not using like the original amount or the known amount. We're actually using an average. So next one, percent difference. For percent difference, we are strictly figuring out how far off it is from the distance, all right, from the average of the two. So we're going to take the first value and subtract the second value. You'll notice we still have these absolute value marks. And we are going to divide it by the average of the values. How do I find an average of two values? Average. How do I find an average? Right. There's two values, so you add them together and divide by 2. All right, so let's look at this example. We have Suzanne is asked to determine the volume of a cylinder. Using water displacement, she arrives at the answer 15.64. Then she measures the dimensions and calculates a volume of 14.01. Find the percent difference, okay? So percent error is what you got minus what you expected divided by what you expected. That is percent error. This is percent difference, all right? So for this one, we are just going to subtract these two numbers here. That's going to be my numerator, 15.64 minus 14.01. It will be positive. But now I need to divide by the average, all right? So my average then is going to be these two. If I'm just calculating the average over here, I'm going to add them up and divide by 2. All right, what is my average then? What is my average? All right, so this average is 14.825, all right? So if I subtract these two, what do I get if I subtract these two? 1.63 divided by 14.825, and I am going to multiply that by 100 once I get that answer, and you should get approximately, when you round, 11%. So in your calculators, you're going to divide these two and then multiply by 100. All right, so the key is that you know how to find an average. The average of two numbers is just add them and divide by 2. All right, so you need to know these terms. Percent error is going to be what you got minus what you expected divided by what you expected. Percent difference is the difference of the two things you got divided by their average. Okay, so make sure you know those terms and the difference in those terms. All right, I want you to try one. All right, so check your work. She determined it was 72.2 when it was actually 78.2. Experimental error is just the subtraction of those. -6 degrees was her experimental error, right? 72 minus 78 was -6. All right, absolute value of that divided by what she expected and then multiplied by 100 there, which I just did that by moving my decimal, but you should have gotten 7.7% as her percent error then. Any questions on those two?